Okay, thanks everyone for coming. I'm going to get started. It's 2:15, so lots of stuff to go over, so I figure I'll get started right away. So thank everyone for coming today. My name is Newman. I'm Chief Technology Officer and founder of a company called CloudCheckr. And what I'm here today to talk about is really practical steps to help you not end up getting hacked in your AWS environment. And there's a couple things I want you to take away, but the most important thing today is to go home and understand a little bit different how you secure what you have running in Amazon. It's very different than what you have running in your data center. Some of the principles are the same. The basic ideas are the same. The security tools that we use in our data centers today are very mature. They've been around for 10, 15 years. As you move into the cloud, a lot of that maturity goes away. There's a brand new world. It's a brand new set of tools, a way to think about things, methodologies, all that. So you just want to make sure that you've thought through this and you understand a changing perspective of the world as you move into the cloud. So your perspective changes. You have to rethink things. What is perimeter security in the cloud, right? What does that even mean? How am I going to secure my business applications in Amazon? What are the concepts like intrusion prevention, intrusion detection? What does that mean in the cloud? Does that mean sticking a traditional IP IDS device into my cloud and running it there? Or does it mean something entirely different? All these things change. How do I do penetration tests? Whole new set of rules around that. How do I do vulnerability assessments? I have elastic clouds. How does that change? It all really changed. Our perspective is very different once we move to the cloud. We had our data center and we had our servers and we all loved them. And what was perimeter security in the old world? What was it? You would go out there, you'd run these tools. You'd have tools like Nmap. You'd have tools like vulnerability assessment tools that went out and swept your IP range and looked for what was running there. So inventorying was a matter of doing IP port scans, things like that. Perimeter assessment was you'd hire somebody outside your organization, you'd give them some points to go start to break into, and they do scans against those. They try to connect through it. They try to find all kinds of vulnerabilities and issues. And then they'd look at things like your wireless networks. Can they break in through wireless networks? Can they break in through somebody's dial-up back in the day, although we don't have those problems anymore. So that's really what we used to look like. But a lot of that changes, right? Because how can you can't just scan an IP block for what you have running in Amazon anymore. So what's really different? Well, first of all, your physical assets, right? Your physical assets are secured very, very well these days. I mean, in almost 99.9% of the cases, Amazon is securing your assets better than you used to do it. And I could tell you some stories, even trying to understand where the data centers are or what AZ it's sitting in is very difficult, right? And that's a good thing from a security perspective. They have armed guards around the building. They have, availability zones. So the idea of physical security, and I think it's interesting because I had a conversation with Jeff Barr, who's the chief evangelist. I think that's his role here at Amazon. And I was having a conversation with him, and I said, I'd just love to see what a data center looks like, what an Amazon data center looks like. And I said, well, tell me what it looks like. It'd just be cool to know. He said, they don't allow me to know where they are or to go in them, right? So if he basically said they take these containers and they just plug them in, and there's almost no humans that go in them. So I mean, it really the security is really there. It's really other than if you're the NSA or something like that, the security is probably tighter than what yours was. But what does it mean? It means that really the idea used to be you'd be afraid of somebody stealing a hard drive, right? Jumping over a fence and stealing a hard drive and then going and stealing your data. What's the equivalent of that in Amazon? It's somebody stealing an EBS snapshot. And how would somebody do that? They don't do it by jumping a fence anymore. They do it by using the API. So the Amazon API really becomes a virtual security for you. So when you're thinking about virtual security, it's not physical security. When you think about physical security, it's more virtual physical security, which is a little redundant. But the idea is protecting those access keys, protecting your API has become the new physical security. The ability to prevent somebody from wiping out a drive, copying an EBS volume, taking snapshots of your database, that's your new physical security. And the idea of physical security is morphed as infrastructures become virtualized. In this, you have ephemeral assets. They auto-scale. They are elastic. They go away. We need to rethink how we do things in order to secure that. It's a little bit tricky because usually I have slides to help me. I have to kind of look over my shoulder to know what I'm supposed to say. So I hope you guys can still hear me okay. So a lot of the principles are the same. Things like the idea of defense in depth, right? That's a basic security principle. You don't want just a firewall because you got to assume people are going to get past your firewall, or you got to assume you have internal threats, those type of things. So even in the old world, you set up a firewall, you'd set up multiple levels of firewall, you set up encryption on your data, you set up access control, you'd set up auditing logs. Those type of principles still apply. It's just really an implementation that's very different. The idea of reducing your surface area. You want to reduce your attack area. Those are all principles that apply very much. Some of the attack vectors don't change, though. Think about like application-level vulnerabilities, things like cross-site scripting, SQL injection. Those are attacks that go straight over port 80 or 443, through an ELB, through a firewall, through your VPC, right into your web server, and then into your database. Those type of attacks really are exactly the same. So if you're going to do those web application-level assessments, really the same issue. Operating system vulnerabilities still exist, even if you're hosted in the web or hosted in the cloud. Database vulnerabilities still exist if you're hosted in the cloud. So those are really the same. Some things do change, though. Think about this. So there's different examples. For instance, the idea that Amazon, and I don't know if you think about this, but Amazon is actually a very homogeneous environment. Right? So you do have a lot of AMIs, but at the end of the day, it's not nearly as heterogeneous as your network at home, which has a lot more different flavors of things. More or less, in Amazon, you have you probably have a dozen different flavors of Windows. You have a dozen different flavors, probably more than that, but a much smaller set of Linux instances. And when you do spin something up, you're going to auto-scale a single AMI that's really hardened, or it's a set AMI, and then you're scaling that up. So a lot of your infrastructure really is very homogeneous. What's the good and bad of that? So the homogeneous, it's good because if you can spend a lot of effort securing one AMI, and even if you scale it out to 1,000 servers, if it's locked down really well, then your security is very, very high. Right? So versus if you had 1,000 different servers that were not all based in the same AMI, then what happens is every single one has a different set of security issues. So it's very hard to lock down 1,000 servers. It's relatively easy to, or more manageable to lock down one server and then scale it out to 1,000. But what it does mean, the other side of the coin, though, is that if one issue comes up in that AMI, then all 1,000 servers are vulnerable. Right? So if somebody can break into one, they can break into all. So there's good and bad over the fact that Amazon and the idea of elastic cloud is actually a very homogeneous environment. The other idea that you have to think about is this idea of polymorphic targets and polymorphic mapping. Right? So again, you have an auto-scaling environment. If somebody happens to break into one of your workers that's sitting there running and part of your auto-scaling group, if they break into one of them, that could be entirely gone in 10 minutes or an hour or a day. So there's the idea of, for instance, advanced persistent threats. One of the bigger challenges, not necessarily somebody breaking in, but somebody breaking in, getting access, installing rootkits or whatever it is, and then having access for the next year because you don't even know they're there. That's called advanced persistent threats. On an Amazon auto-scaling environment or in any cloud, the idea of that comes and goes away so quickly that those advanced persistent threats become much harder for an attacker to keep going. So you may have an EC2 instance that ends up getting cracked or exploited, but it goes away in a day, right? Because you spun it down and then you respun a new one up. You respun it up with a different IP address in a different location, and so it's very hard for the hacker to necessarily map your network to keep those advanced persistent threats in there. So the other thing that's very different in Amazon is you don't have a lot of access to what I would consider network sniffing. You can't see the packets that are coming across, right? So if you think about it, Amazon does a great job of preventing a lot of the attacks from even getting to your infrastructure. So they're dropping a lot of these kind of SYN attacks or all kinds of flooding attacks, packet flooding attacks. They drop that, right? So If you just put a server out in the internet, you might see thousands of attacks a day. Versus if you just put an EC2 instance out on open to the world in your AWS account, you're probably going to see hundreds of attacks. And what does that mean? What it means is that Amazon is filtering out a ton of them. And they could do that because they have lots of great tools that help them see what are attacks from IPs, be able to block those IPs so they can really filter it down a lot. But it's also bad because you actually can't see all the attacks. And so if you're really an advanced, if you have an advanced team, you don't have access to as much data to understand where attackers are coming from. What are they trying to do? And that's not necessarily good because at the end of the day, if the attacker is banging on your door and you can see that he's banging, you actually know he's kind of there versus if you don't know he's banging on the door, when he finally breaks through, it kind of catches you a little bit. So there's good and bads about all these different principles and ideas and advantages and disadvantages. Does that make sense? So does everybody get this so far? Is this, yeah, seeing a lot of head shakes. So good. Let me see if I can. The other thing that I like to think about, and this is one of the dangers, obviously, again, of heterogeneous environments. What's the biggest threat to Amazon and to all of us is that we find vulnerabilities, for instance, in a Zen hypervisor, right? That's probably the biggest threat to the cloud is, what if there is some kind of buffer overflow or something that allowed an attacker on an EC2 instance to gain control of the hypervisor? And so there's lots of protections and lots of controls around that, and there's always ways to mitigate it, but that's really probably the biggest threat to us all is that one type of vulnerability, one mistake somewhere in that hypervisor could end up exposing everybody. So that's really the biggest risk of a homogeneous environment, everybody running on a Zen hypervisor, is that type of vulnerability can really be dangerous. On the flip side of it, if there is one vulnerability, it can be fixed very quickly by an Amazon. They can roll it out, and then within a couple days, the entire world is secure again, right? So what happens in a data center is you may have a vulnerability in 1,000, the Heartbleed comes out. How hard is it to get all your servers fixed for the Heartbleed vulnerability? It takes months and months and years, and you probably still have ones that are not fixed, right? So that's the disadvantage of the heterogeneous environment. Is so hard to go fix all the issues across everything. The advantage is that when that vulnerability comes out, nobody can just take over your entire network. They just can only take over very small pieces, things like that. So again, advantages and disadvantages over the different models. So what do you do for perimeter assessment in the cloud? So in the old world, perimeter assessment was all about doing an IP scan, doing a port scan, seeing what are all the, I know this company has this IP range. I'm going to go try to beat that up. That doesn't work anymore, right? The idea is you can't just go running IP port scans on Amazon, particularly if an attacker is trying to go after a specific target. It just doesn't work because you don't know which ones they're talking to. You don't know which ones are there. So really, to really find your perimeter, it's really about collecting all your configuration information. So it's all about knowing, okay, what are all the VPCs I have set up? What's everything public in there? What do my routing tables look like? What do my IAM policies and my NACL rules look like? So it's really about a really rich set of configuration. So now, what's interesting is, we actually have clients who use this to feed into their scanning tools. So for instance, you may have 1,000 accounts or 100 accounts, right? So it's very easy to go out there and take your existing tool, a Nessus, a Rapid7, whatever your scanning tools are, and if you know you have one website, you can point your tools at it, you can see if it's vulnerable, right? The real challenge in the cloud is that, in your data center, you'd know all my resources are within this block, so I could just test all those. In the cloud, the question is, I have 100 accounts, how am I going to know all the endpoints I have to test? So that's the real challenge. And so really, what it means is you have to get a complete inventory of everything you have running in there, all the VPCs, everything running under EC2 Classic, everything running under S3, and then start looking at each one at a time and saying, what's public there? Assess that, and then, for instance, get a list of elastic IPs for your organization and feed that into your vulnerability assessment tool. Or get a list of all your your EC2 Classic instances, your EC2 instances that are running Classic, feed that into your tool, right? So it becomes much more of an inventorying exercise of how do I know where all my assets are. The other thing is that if you're scaling up 1,000 instances, what does that mean, right? Am I going to go run on every one of those IP addresses and a complete vulnerability assessment? That doesn't make sense either, for a couple reasons. The first is they're all exactly alike, right? So you may be able to just run against one and apply that to all of them, right? If they're very elastic and they're going and coming, disappearing on a regular basis, that may be safe to do. But if you have a cloud, for instance, where it scales up and then those instances stay there for years or weeks or months, the other problem is that it may start as an AMI with these set of parameters, but then, for instance, somebody logs in or reconfigures it, or something changes on it. So the challenge still becomes, you can't just assume that I scanned the AMI, and so this instance is based on that AMI, so it's secure. It may have been reconfigured. So again, you have to evaluate the situation. Is this an auto-scaled application, or is this an AMI that was built from an auto-scale that I can guarantee hasn't been reconfigured from the original AMI? Or is this something that was scaled up from an AMI that may have been secure at one point, but it's been a while and it may not be secure anymore? So those are the type of things that you have to think through. Because I've spent time having conversations with people and saying, can I just scan on one AMI and assume everything is secure and not scan the other 2,000 AMI instances that I built off of that? The answer is maybe, right? There's never any yes or no. It's always maybe. So any questions so far or thoughts or? No? OK. So quiet is either good or really bad, right? So either everybody's like, damn, I didn't think about that, or they're like, this is stupid, right? So there's rules for running pen tests. And pen test means a lot of things. It doesn't just mean pen tests. It means if you're doing vulnerabilities, discoveries, whatever the terms you're using on there. But very clearly, Amazon does not need you going and running a bunch of denial of service attacks on some random IP addresses, even if you own them in the cloud, for lots of reasons. Remember, they're shared resources. So somebody beating up your box or your elastic network interface or whatever it is, doing floods on it or whatever, can really affect other customers. So that said, they have policies that help to make sure that everybody doesn't get affected by somebody else's security testing. So if you go up there, there's a whole couple-page form to educate you on how you do this, to say, OK, you can do these type of things, but you can't do these type of things. And usually in my presentation, I'd switch over and show you the page, and we go over some of the stuff in there. But you'll have to go yourself to that web page. But there's a lot of interesting things on there that you can read through. There's limitations. For instance, that you can't do it. You're not even authorized in any way to do it on a T1 micro, right? And I think on an M1 small is the other type. What does that mean? It means, and I don't really understand the behind the scenes, but it means that the T1 micro is even more vulnerable to if you tried to beat it up with any kind of security thing. It can really affect other people on that box. So they really don't want you to do that and bringing down other people that are running on a shared instance that you are. So what do you do in that case, right? So if you have an app that's really running on a T1 micro, and you need to test it because you need to pass a PCI compliance, or you need to get your HIPAA certification, whatever it is, you got to run vulnerability tests on these servers. So you have to start thinking about, OK, I'm going to actually maybe make a snapshot of it, bring it up as an M3 medium to run my security tests on it. So is that the type of thing you have to do? So these are where you have to actually start thinking outside the box, understanding what do I have to do a little differently. But you can't just say, well, I'm not going to security test it. I'm not going to run my vulnerability tests on it, because you need to make sure it's secure. So so the M1 smalls or the T1 micros. And then when you go out there, I wish again I could show you the demo of the pen test report. So you have to fill out a report, and they ask you for a lot of information. They ask you, and it makes sense because Amazon wants to. They do a lot of filtering out of attacks themselves. So if you're trying to run your own tool, Nessus, or whatever else the tool is, against something sitting in your environment, they actually would love to stop your own tests from hitting there. So by filling this out, you're helping them make sure they're not blocking your own testing. And it's just making their lives a lot easier so they can know who's actually trying to break in and who's actually just doing assessments on themselves. So you go fill this out, and then you fill out things like what's your name, your account. You actually have to log into your console to do this. You have to fill out like what date you're going to do it, what IP you're going to scan from, which IPs you're going to scan, things like that. Now that's problematic because usually it's very hard to know, well, where am I going to scan from, right? Particularly if you're using a managed service provider, some third party. You can't always get the name of who you're going to scan. I mean, for instance, with our software, people are often asking us, okay, what's your security policies? And we had a company that said, well, we'd like to run tests against your environment just to make sure it's secure enough. And so we said, that's fine, but we have to fill out this form to allow you, a third party, to assess our site. What's your source IP addresses? Because we need those source IP addresses to authorize you to scan Amazon, right? So you can see how it just creates a little bit more friction and complications around how you're going to do these type of assessments. So, and interesting enough, I never heard anything back from them because they probably said, geez, we can't figure out what IPs we're going to scan from. So the whole thing went away, right? So the best way to get somebody to not bother is make their life difficult. So where was I going with that? So you have to give IP you're coming from, the IPs you're going to scan. Again, what do you mean the IPs I'm going to scan, right? I am an elastic cloud with ephemeral IP addresses. I don't have any clue. They're going to change tomorrow. So I can register today with 1.2.3.4, and tomorrow it could be 1.2.3.5, right? So it becomes, again, problematic to do that. So you got to know a lot of information, a lot of prep work. But rightfully so. We really need that kind of protection. But what else? The thing is that also only assumes that EC2 is the attack surface, right? So, but that's not the case. Amazon is a very robust, complete platform with many moving parts. The hacker's not sitting there saying, well, geez, if I can't get into EC2, let me go somewhere else, right? How does a hacker think? A hacker says, well, EC2 is probably locked down. Let me go check, how does your RDS set up? Let me go check if you have any S3 buckets exposed. Let me go check what your SQS queues look like, right? So it's all about finding that weak link. The hacker's going to try to find the weak link. And this goes back to what I said earlier, right? Which was you want to reduce your attack surface. Reducing attack surfaces is what keeps us as secure as possible. What does a VPC do? Does it stop people from getting to our data? No, because you have a VPC, but then you open it up to port 80, 443, whatever it is. What it does is reduces attack surface. And by reducing the attack surface, it's much easier to protect a small attack surface than a very large attack surface. Why is EC2 Classic so insecure? Because it's a very, very large attack surface with a lot of holes in it. So the idea is you want to reduce your attack surface, but you have many different services in Amazon, and we'll talk a little bit about that. But as well, you're going to have hundreds of accounts, right? And unless you're a small company with a small number of accounts, but many companies have hundreds or even thousands of accounts, and that's the real challenge is you can lock down 50 of them, but if you leave one open, well, that's all the hacker wants. He doesn't need you to leave 5 of them open. He needs you to leave 1 of them open, right? So that's where the challenge comes in. So, you need that complete inventory. If you don't know what you have, it's very hard to secure it, right? So it was actually easier to secure it when you didn't know what you have in the data center because you just put a firewall around the whole world. But then, of course, what that meant was anyone within your organization behind the firewall had an easy time because it was the hard, crunchy outside and the soft, mushy inside, right? So, but now that we don't have this firewall around the whole world, we're in this public cloud, you need to make sure you have a complete inventory of exactly what you have running and understand, how can people get in there, right? Because it can be complex. I have a server, and I know that I have a VPC set up. I know I have network access controls. I know I have security groups. But how hard is it to figure out if a hacker sent a packet to port 80, does it get to my server or not, right? As a human, it's very, very difficult to read through all those different layers and to be able to resolve in your mind, does that packet make it there or not? Does that attack make it there or not? So that's really the complexity of the situation. So, but fortunately, that's the thing that computers are very good at, is calculating that a packet can come in and hit my server on port 80 because my NACLs are set up this way and my security groups are set up that way. So what are the things that we got to think about? EC2 Classic, again, this is one of those early adopters have this a lot, right? And so, and one of the challenges is if you're really in early with Amazon, then you were probably on EC2 Classic, and you might have thousands of instances out there, and then it becomes very difficult to get into the VPC world. That's the biggest challenge that the old adopters are having, is how do I migrate into VPC? Right. Well, I mean, so certificates are interesting, but I don't know that they apply to how do I, a certificate could help me, for instance, secure one single server or something like that, but it doesn't allow me to secure the entire infrastructure. And yeah, whatever you do behind there, you can set up in a different way that you can secure it all with a certificate. I guess it really depends on that. But a certificate doesn't really fix. Strong authentication doesn't fix, the fact that I have MFA on doesn't fix the problem if I left an S3 bucket wide open, right? And that's usually what happens is you think, okay, these things are secure, I gotta lock them down. So you set really good security on the hard things, and then you leave an easy hole like an S3 bucket wide open, right? So that's where I like to get away from the idea of, I'm going to really put some really hard security here on 98% of my infrastructure and leave 2% of it wide open. That's really where the problem hits. I'll give you another example. I work with customers all the time, and the biggest. Let me jump ahead to S3, right? Because this is the low-hanging fruit. That's the biggest security issue right now. So it's not a security vulnerability, it's a human error, right? What are most security issues? They're human errors. They're not computer errors, right? So S3, you can have 100 buckets in the count, unlimited number of objects. I see people with billions of objects. You can have them in a region across multiple AZs. They can't be hosted in a VPC. Although just recently, we do now have the capability to take an S3 bucket and put a policy on it so that only endpoints from my VPC can get to it. So there is some capability to do that. But the vast majority of S3 buckets are public to the whole world, and their access to them is controlled by IAM policies. So you can't sit between the client and the storage, so you can't monitor who's touching it. You can see after the fact there's log files that you can monitor, things like that. But you certainly can't put an IDS in between it, things like that. So it's controlled through access control policies, IAM policies, bucket policies, and query strings. So there's 4 methods that you can use to control that, right? So that's one of the challenges is there's so many methods to control it that what happens? Those darn humans get in the way and they screw up one of them, right? Because all it takes is one person that didn't understand that setting up the backup policy this way opens everything up to the world. So that's really what happens, is not some advanced check, but some really silly thing like, I'll give you the example where I started with this was, somebody, one of our clients had out on their website, on their S3 bucket, they put like an HR form up there. And it's read-only. People are just going to download this and print it and then fill out their HR stuff, right? It's a Word doc. They put it out there. But for some reason, they put it with everyone allowed edit permissions. And they didn't even put everyone allowed write permissions, but edit permissions, right? So what does that mean? A hacker just has to find that. They can edit the permissions to, so anyone on the internet, not even a hacker, anyone on the internet that knows about this can find it, change the permissions to write only, and replace that Word document with one that has some kind of VBS virus in it, right? Does that make sense? So somebody downloads that document to fill out the HR form, and bam, their workstation gets hacked, or a Trojan on that. And then once they have the Trojan on your workstation, then they're going to install a keylogger. And then when you go to log on to the Amazon Management Console, you put your username and your password in there, and bam. That's the string of how attacks typically happen. It's not through some magic, I sent a packet and it's somehow magic. It's not like in the movies, right, where you type really fast and you hack things, right? Somehow the faster you type, and if you have 4 screens, you hack it even faster, right? It's by finding silly things like some human who didn't realize putting out an HR form on an S3 bucket and somehow leaving everyone edit permission accidentally, probably because they saw those access control lists and they didn't really understand what edit permission meant, right? Because there's an HR person up there, and what the heck do they know, right? So you're supposed to laugh at that one too. So, and so those are the human problems. What's the other big thing that hits everyone, right? How does everyone get hacked in Amazon? Most common way, GitHub, right? Like how many times you guys know Rich Mogul? He's a very, very popular security blogger. And 3 or 4 years ago, so he's a security blogger. He was a Forrester research analyst that wrote about security for 20 years, right? And what did he do? In his development environment, he wrote some little sample code, and then he took his code and put it on GitHub, and some hacker or probably not even a hacker, right? Probably a script kiddie or somebody playing around was like, wow, somebody just posted their access key. Let me take that, go put it into my code and see what happens. Let me go see if I can spin up some EC2 instances, things like that, right? So this is a common occurrence. It happens, and it's so common that Amazon actually has a process in place where they monitor GitHub, and if you accidentally put your EC2 keys up there, they'll send you an email within a couple hours saying, dummy, take that down, please, right? So it's usually not fast enough before somebody goes and screws with your account. So, that's, if the smartest security guys in the world are doing this, what chance do the mere mortals like us have, right? There's a ton of them, right? There's lots of them. It's just a case of if you're Rich Mogul just throwing together a sample code, you don't think about, well, I should put it into a file, into a configuration file, or I should use some other secure method. There's lots of secure methods to do it. The fact is those damn humans keep getting in the way, and they're lazy, and they don't like to work, and they want to get paid for that too. So that's a big issue. Go home and make sure that you don't have any bucket with full control, with write ACP, or with write to anyone ever. So now let me jump back to, so EC2 Classic is the old way. Every time you create an instance that's an EC2 Classic, it has a private IP address, but also has a public IP address. So again, information is knowledge, where I've talked to people who thought without an elastic IP address that people couldn't get to this. They can still get to it, right? It's much harder. You have to almost stumble upon it if it's an EC2 Classic instance, because that public IP is just some random one that Amazon made up. But it still exists out there. So you're very vulnerable to, again, what I would call script kiddies. There's script kiddies out there that know this is the IP range that Amazon hands out to EC2 instances, and I just pound on them to see who started up an EC2 instance, didn't realize they have a vulnerable version of Apache XYZ on there, and I can take over another box, right? So that's, again, how things happen. But again, this is, each target, each instance is its own target, its own security risk, and that's where the real challenge is with EC2 Classic. EC2 VPC, makes it much easier. I mean, you still have to secure your stuff, but you can put throttles and bottlenecks at the VPC level. And then everything that's coming through can be monitored there. So that's ideally what you want to do, is stick everything you can in the VPC. And this is where it becomes interesting, is that so you have security groups and you have your VPC network access control list. So good and bad of both, right? Your network access control list is very much like your firewall in the old world, right? Because you could just set it once on a network, on a virtual network, and everything has to go through that to get into any of the resources that are sitting inside of it. So a couple differences, though, is that VPCs and network access control lists are not stateful. So they're stateless. So meaning if a packet comes in on port 80, and the way IP works is it comes back out on port 2000 XYZ or something like that, right? It comes out on a high port. So it doesn't just come back out on port 80. Now, when you have a stateful firewall, the firewall knows something came in on port 80, and when it goes back out, it knows, even though it's going back out on port 3298, it knows it's associated with port 80, that the request that came in, so it allows it back out, right? So with a stateless firewall, it doesn't. So if you want something to come in through port 80, you basically have to open up everything going back out from port 1024 and up. Right? Which just becomes problematic, right? That's not good security. So your security groups are stateful. So they actually do a great job of that. So you can just open port 80 on your security group, and then you don't have to worry about the outward stuff, right? So you actually have both options. You have this. You can do stateful packet restrictions at your security group level, or stateless at your VPC level. Now, so then what it really means is it's much better to use security groups than it is to use network access control lists, because it's just it's not great to have to open up everything above port 1024. But security groups are more of a challenge, because now you got to manage. And believe me, again, what's going to happen? Somebody's going to spin up an EC2 instance and forget to put the security group on it. So one of those damn humans again is going to do that. And you don't know about it, right? So it just so it allows the errors to be made by a human who's spinning up EC2 instances and forgets to click the right security group when they instantiate it. So now at the VPC level, if you had it set up your VPC, you could set it up once at the VPC, and even if some dummy screwed up and didn't put the security group on it at the inside of the VPC, it's still protected. So you're starting to see the different good and bad. So there's never a silver bullet. Right? So it's really trading off strengths and weaknesses. So again, EC2 VPCs are great. VPCs are great. Just realize, again, that you can put EC2 inside of them, RDS, Redshift, Elasticache, again. So you should be putting any of those. If you have any Redshift, don't put them out as classic. Make sure they're in a VPC so you can control them. So S3 we talked about, RDS. How's our time looking? Oh, so we got 5 minutes. Okay, I gotta go quickly now. So I often talk way too much. So RDS, the same thing. Put it in a VPC. Don't ever leave it exposed. RDS databases are not robust. I mean, and it's not. Let me take that back. It's not what I said. What I mean is, SQL Server databases, Oracle databases, MySQL databases, they are meant to be enterprise applications. They're not designed to be like a web server. Web servers are designed to withstand attacks from hackers. Those are not designed. They're still zero-day exploits. They still don't have strong password locking. They don't have all these things. They're designed to be behind a firewall, honestly. So don't put your RDS out there publicly. Always put it in a VPC. Make sure you never click that option, publicly accessible. Make sure your security groups are locked down on them. Make sure those are tightly controlled. So Amazon SQS. So this is another piece that does not live within a VPC. So what does that mean? It means we have to go make sure that it's locked down. It also has its own access control system. It has policy documents. So you have to make sure that even if you lock down all your VPCs, all your EC2s, all your RDS, but you left the hole here, you left public in that policy document, you have a security hole, you have an avenue in, you have some surface area that you need to protect. So, and people always wonder, well, what's the issue with opening a public SQS queue? You can do attacks like SQL injection and cross-site scripting attacks through an SQS message. Think about this. You have some process that's pulling messages off of SQS. Now, if you're going to put your little standard SQL injection attack in there, like a single quote and then drop database XYZ, now some application's going to pull that SQS queue message off of there because you left it public. It's going to try to insert it into a database somewhere, and you're going to have this little SQL injection attack in there. So it's really just a different avenue of what people are very familiar with SQL injection attacks on your website, but don't think through that can also happen in your SQS queues. That can also happen in any input that can come from an attacker. You got to make sure you don't leave that unsanitized. So SNS, again, it has the same kind of concept of a different set of, it's secured differently than everything else, right? So again, you may have experts in everything else, but if your co-op set up the SNS topic and left it public, he may have exposed your entire organization. So that's what security is about, locking down 100% of the things, right? Leaving this one hole could end up being your downfall. What's your threat? Is it the internal threat or is it the external threat? We often think about, and it's often sexier to think about the external threat. Hacker groups, some government, some foreign government that's trying to hack us, right? That's the cool one. But really, your bigger threat is the people that work for your organization, the people that sit next to you, right? Ooh, so 1 out of 3 people here is the real threat. So, so think about that. I mean, so your VPC isn't going to do anything when the fact is that a disgruntled employee or some activist or something is really your threat, and he works for your organization. So a lot of this you have to think through. It's not even just that finding out who's attacking you through the network, but who's accessing data. Activity monitoring is a critical piece of what's happening. So CloudTrail, right? So using that CloudTrail is important. And I like to talk about, a lot of people do use CloudTrail, but what do? They set it up only in one region, the region that they're using. Go set it up in all the regions so that you know if somebody's doing something in a region they aren't supposed to. So, so make sure you're using CloudTrail properly. And then make sure you're locking down those files. Create kind of tamper-resistant files. These are all things that you probably are doing on your syslogs, your window log, things like that. But you got to do it for CloudTrail as well. CodeSpace. What happened with CodeSpace? They had everything secured. They got, somebody stole their AWS management password, a console password, right? And then sent them an email and said, give me some money or bad things will happen. And they did exactly what you shouldn't do, which is, okay, I'm going to go try to disable his account, disable the account that we think he used. Well, this was a clever hacker who set up a second account, and as soon as they disabled his first one, he said, F you, log in with the second one, and started deleting everything, right? Even your backups, right? Because the fact is even your backups, if you have an AWS account and you just delete all your backups, well, that becomes problematic. So, so they were out of business, because of this one thing, right? So, so it's a little bit of a lesson. Think about not just backing up, but how do I back up into a different account? It's a little bit funny is now our data centers might be our DR site soon, right? So there's a little irony, right? So you might want to take some backups of what you have in your cloud and move it back to on-site so that if somebody did, think about this, Netflix, right? If somebody at Netflix has the right to click one button and delete the whole Netflix account, right? So your whole business is running on the fact that that one person isn't totally crazy or a total jerk, right? So think about how do I do backups of that? Maybe I need a second Amazon account that doesn't have rights to the first one that I can back up to in some way. So lots of things like that. That's probably the thing that keeps me awake more than anything is that type of scenario. Is one of my DevOps got really upset with me. Could they take down everything? So, and we have one more minute. CloudCheckr, we write tools to help you with all this. So please check it out. We do cost optimization. We do best practices. We help you scan for all these issues, help you see where you've left that S3 bucket exposed. Help you didn't even know that there was a public SQSQ. We highlight all that for you, make it very easy. It's a software program that will do that for you. Very intelligent, goes very deep. There's a free evaluation, so come check it out, cloudcheckr.com. We have a booth here too, so please come. If you come to the booth and buy something, it helps me keep coming here and doing these educational pitches and all that. So I don't think we're even going to have time for questions, but if you want, come up afterwards, give me, and I could talk through and stay as long as you want. But thank you for coming. Thanks for your time.